to neutralize the reflex. And at the very end, subtract a working distance to come up with your final prescription. So what about astigmatism? Now this has been pretty easy so far. If it was this easy, anyone could do it. It's not an issue. Let's look at another eye. Step 1, start with width. Good. We can proceed to step 2. Let's start adding some power. We'll add a +1. Okay, we're still with not quite there yet. So let's check the other axis. Not quite there yet. We're getting there. Let's add another diopter of power. All right, +2. Let's try this. It looks like we maybe have hit it here. In fact, I think we have. Okay, let's check the other axis. Uh-oh, we still need some more power this direction. Don't worry about axes. Is it 90? Is it 180? Just keep your instrument in the same position. Set that lens aside and keep going. Set it aside. Keep going. Start adding power, and we'll continue moving our beam left and right until we get it. Boom, we've got it. And so these are our 2 lenses. Now, don't try to do the math in your head while you're doing this. Here is how I calculate the prescription based off this. The sphere is +2. The cylinder power is the difference between them, so it's a +2 +1. It's just like using a lensometer, right? You start at one number and the amount you shift it is your cylinder power. Same thing with this. So this is a +2 +1, and the axis is at 90. And we know it's at 90 because our light beam is going up and down. And if you're not sure, hold your light beam up to the phoropter and look at the little angular degrees on there and make sure it's lined up with 90. And that's how I remember it. I don't try to think I was moving left and right, but the axis is always 90 degrees off the power. It'll confuse you. Just put these lenses aside, and at the very end, look at it. This is a +2 +1 at 90. So we write it out. A +2 +1 at 90. But remember, there's one last step, and that is to subtract your working distance. And you subtract it from the sphere, and that's all. You don't need to subtract it from your cylinder power. So the final answer here is a +50 +1 at 90, and that's the prescription. Let's do another example. All right, step 1, always start with width. You have to start with width or you'll become confused. All right, so we've got width motion in both directions. Let's start adding power. Still have width, so not enough yet that direction. Let's try this direction. No, still need more. Let's add some more power. Try +2. All right, we're getting close. Our beam is getting a little wider. We're nowhere near in this direction though, so let's keep adding power until we neutralize these things one at a time. So let's try this way. No, still need a lot more this way. However, this way, we've got it. This is the right prescription in this direction. Let's set this lens aside. Set it aside or you'll forget. Just set it aside. Keep adding power, and let's go back to the other direction until we fix that too. Still have width, not quite there yet. Let's try this +5 lens. Perfect. Now we have the right power for that meridian. Set the lenses aside, and now you can start thinking about the numbers and writing these things down. So this prescription is what? It's a +3 +2, it's the difference between them, and the axis, we can just look at where our light beam is oriented right now. It's going sort of horizontal. We know the axis is at 180. So the answer is a +3 +2 at 180. Write it down. Don't do the math in your head, just write that down, and at the very end, subtract your working distance, and our final prescription is a +150 +2 at 180. Not too bad. Let's do another example. This is good practice. All right, we've got against motion. We can't start with against motion. You're going to get confused. So what do we have to do? We need to back off because you've got to start with width before you can figure these things out. So let's put a -2 up. Good. We've got width motion that way. We still have against. This is no good. You cannot have against motion at the beginning. You'll get confused. So let's throw a -4. If I got to go to -10, so be it. Now we have width motion in that direction. We have width motion in this direction. Now we can continue and add power until we neutralize it. So let's add a diopter, -3. We still have width, not quite there yet. Let's check the other direction. We've got it. We've got it this direction. Let's set this lens aside. Set it aside, you'll get confused. Just set it aside, get a stronger lens, and keep going the other direction. So we're going to add a little power. No, still need a lot more, it looks like. That's surprising. Okay, let's add some more power. -1, let's try that. I think we may have it. This might be it. Do I try it for more? Do I dare? Let's try plano. No, plano's too strong. The -1 was the right one. So put these lenses aside. Put them aside. If you don't put them aside, you'll get confused. Now you can write it down. This is a -3. The difference is a +2. And the axis is at 90. You write this down, -3 +2 at 90. Then you do the math. Subtract your working distance, and the final answer is a -450 +2 at 90. Not too bad. All right, we're going to do this one more time. We have against motion here. It's no good. Can't start with against. You got to have width. You can't continue. No, still a problem. It's okay this direction, but it doesn't matter. You got to start with width in every direction, otherwise you'll become confused. So let's throw a -4. All right, we definitely have width this, so this is good. Let's try the other axis, make sure it's still good. Now we have width in all meridians. We can continue with step 2, which is where we add power to neutralize the reflex. Try -3. I think we've got it. We've got it this direction. So let's set this lens aside before we get confused. And now we'll continue to add power and work on the other direction. So we'll try a -2. No, not quite there yet. We're getting closer, though. I think we're getting closer. Let's try -1. I think we've got it. I think this is it. Set it aside, then write things down. This is a -3 plus 2. That's the difference between them. And the axis is at 180. Write that down. -3 plus 2 at 180. Then, and only then, do you subtract your working distance from that sphere power, and your final answer is a -450 plus 2. All right, we're going to do this one more time, and then we'll continue on. I know I'm beating this into you, so I'm sorry. Start with against. This is no good. You can't have against motion. You got to have with. Still have against. This is no good. We can't have this. We got to have with motion. -4. Finally we have with motion. Let's make sure it's in both axes. Good. We have with in both axes. Only now can we continue. Let's start adding some power. Step 2. We'll add a -3. Oh, not quite there yet. Let's try the other way. Perfect. We've got it this way. What do we do with our lens? We set it aside. So I'm going to put this on the counter. Go get a more strong lens, and we'll work on that other direction. Still have width. Might need a bit more. Let's get a stronger one. -1. Still have width. You know, actually, it looks like I might need a whole bunch more looking at my reflection here. So let's add more. Plano. That's a diopter stronger than -1. No, not quite there yet. +1. I think we're getting closer. We may have it. This person has a ton of astigmatism. +2. Let's try it. I think we got it. This looks like it's our answer. I'm getting greedy now. We're going to try +3. We've gone too far. So the answer was a +2. So you set these aside. Perfect. And what is our answer here? It's a -3 plus 5. And our axis, as you can see where my light beam is oriented right now, is at 180. So you write it down, and only then do you do the math, subtract your working distance, -450 plus 5 at 180. All right, 3 steps of retinoscopy. Remember these? I know you do, because we just said them like 5 million times. You got to start with width. Then you add the power, and at the very end you subtract. But let's do astigmatism, because all that stuff, well, we've been doing astigmatism. I can take that back. Let's do against the rule stuff. Technically, we've been doing a rule astigmatism, either against the rule or with the rule. Let's do unrule, something in between. We haven't really been doing angles yet. Now, what does that look like? Well, here we go. All right. We've got, uh-oh, what is this? Our reflection is at a funny angle, isn't it? That's odd. So what do? You just rotate your beam so that you're in sync with that angle, and then you continue doing your steps just like before. You got to start with width. All right, I've got width in that direction. This is good. Do I have width this? No, I'm still against. This is no good. We had to start with width. You have to start with width. You'll get confused. Let's try -4. Perfect. We've got width motion that way. We've got width motion that way. Now we continue with our standard retinoscopy technique. Step 2, we start adding power. So we'll add a diopter. Let's see if we got it. Nope, not quite there. We may be close the other direction. Let's try. Perfect, we got it. We've got the prescription that way. Let's take that lens, set it aside. You'll get confused otherwise. Just set it aside. Keep adding power until you get the other direction. All right, we're getting close. Not quite there yet. Let's add another diopter. I think this is it. This looks like it. All right. Set the lenses aside. Yes?
So if on your first pass you see it's at an oblique, you're not going to go with horizontal or vertical. You're going to stick with the obliques.
Yep. I try to get it so that the reflection looks exactly in the direction that I'm moving. And it's hard to figure out sometimes, especially if it's a funny angle or it's a funny reflex, but you do your best. And as far as figuring out this prescription, it's all the same steps. Once again, we set our lenses aside, we look at it, this is a -3 plus 2, and you look at your axis, and if it's not obvious, you hold it in front of your phoropter and look at the angles on that thing. And I'm going to estimate this is about a 90, 120, and so what do we end up with? We end up with a -3 plus 2 at 120. Last step, you got to subtract your working distance, and you end up with this prescription, a -450 plus 2 at 120. All right, so, yes?
I sometimes get confused when I get that scissoring.
Yes. Well, we've been assuming that the eye is a perfectly spherical structure, and the lens is perfectly spherical, and it focuses at a single point. But the reality is the eye has a fair amount of aberrations. The cornea is not perfectly spherical. It has a slope out at the edge, and that slope can cause some distortion. The lens is actually steeper in the middle. It's the opposite, and so these spherical aberrations can cause issues. Plus, if they have a cataract, the center of the cataract may be stronger than the outside of the cataract, and you may have a different movement of the light in the center compared to the outside, so it's going in different directions, and it gets very, very confusing. The key is just to look at where the light is right in the middle of the pupil as best you can, and you do your best. That's all you can do. And sometimes you just don't get it, but you try. But, in summary, 3 steps. Start with width, add the power, then you subtract. And now we're going to test ourselves with a couple of cases. These will go fast. This is the speed at which I retinoscopy, and we'll see if we can figure it. And we're going to do everything in our head. I'll talk out loud just to keep us from getting bored, but we're going to do everything in our head. So here we go. Start with width. Good that direction. Good that direction. Okay. Let's add some power. +1. Not quite there yet. Not quite there yet. Let's add some more power. +2. Okay. 150. Okay, we're getting there. I think we've got it. I think we've got it. Let's put this lens aside and continue on in the other direction. Let's try +2. No, not there yet. +3. I think we got it. This is the prescription. Now if we do this in our head, this is a, let's try 4. I'm getting greedy. Sorry. No, too far. I'm glad I set that first lens aside, otherwise I would have lost it and forgotten. So, what's our prescription? It's a +150, +150 at 180. In our head, we do the subtraction, and it comes out to being a plano +150 at 180. And let's see if we are correct. Plano +150 at 180. That's how we do it. Let's do a harder one. All right. Well, I think we got it right off the bat. Good. So that's a plano that direction. We still need some more power that way. So let's add a +1. No, not quite there yet. Let's add another one. I'm getting closer. Our reflection's getting larger. Let's add another one. I think we've got it. Perfect. Am I getting greedy? I am getting greedy. Let's try it. No, we've gone too far. So let's get that +3 lens out, lay it on the counter before I forget, and our answer is it's a plano +3 at 90, and we do the math in our head, and the final answer is a -150 +3 at 90. Let's see if we've got it. Perfect. -150, 390. One last one. This is our last one, I promise. It's a funny angle. Got to change. All right, good. We've got with motion in this direction. That's fine. We've got against. No, that's no good. We can't have against. You've got to start with, or you're going to get confused. Let's throw a -2. Perfect. We've got with motion that way. We've got with motion that way. We can continue. Let's add some more power to the system. Not quite there yet. This direction. We've got it this way. Let's set our lens aside. We're going to get confused and keep going the other way. Plano. No, not quite there yet. +1. Oh, they've got a fair amount of astigmatism. Not quite there yet. +2. Let's try it. Oh, no. Man, this is a high astigmatism. Let's try another one. Okay, we're getting close. I can tell. Let's add another one. Boom, we've got it. So, set our lenses aside, do the math in our head. This is a -1 +5 total. And the axis is about 45 degrees. You do the math in your head, and it ends up being a -250 +5 with an axis of 45 is our final answer. -250 +5 at 45. I have put this sample in your notes so that you can kind of figure out how this works. The same photo from this last one is in there, so it should make sense. But in summary, there are 3 steps to retinoscopy. You have to start with width, then you can add power to neutralize the reflex, and you may have to do it in different meridians and set your lenses aside. And the last step is you subtract your working distance at the end. Thank you.